Good morning or good afternoon to Sultan. We are from Group 3. My name is Norjela binti Muhammad Nurdin. Number matrix YE 232 10038. And today we will present our analysis on key performance indicators in Malaysian manufacturing companies.
Hello
So I will
everyone,
be
my name
explain
is Muhammad
about part
Grafi bin
1,
Awang and my
construct
matrix number is
appropriate graph chart to compare the relative
YE22110007.
frequency and cumulative
And
relative
firstly, I want to
frequency
explain
between the
about
two
data
key performance
description.
indicator.
So the data set
So
consists of
firstly,
production
relative
cost in a million and
frequency
profit
shows the
margin in
proportion of data
percentage
points that fall
for
within
30
specific
manufacturing companies
intervals,
operating in
while
Malaysia during
cumulative
September
relative frequency
2024,
aggregate this proportion
while
to
the data
provide a
includes a
running
diverse
total.
range of companies
This measure
from
helps
those
to
in the rubber
visualize the
industry to
distribution of
electronic and
production cost and
pharmaceutical.
profit margin.
So there are
So
two
there's a
key performance
four
indicators
method of
analyzed are
calculation. Number one
firstly
is
production
divide the
cost.
range of
So
values
this
into
represents the
equal
total cost of
intervals.
production activities in a million. So
Secondly,
it
calculate
varies
relative
significantly
frequency and
across
cumulative
companies,
frequency
reflecting
using
difference
relevant
in
formula.
scale
And
and
then the third one is create
operationally
frequency
efficiency.
table for
So
both
number two
KPIs,
is our
followed
profit
by
margin.
histogram for relative
So
frequency
this
and
represents the
polygon for
profitability
cumulative
of each
frequency. And
company
then
as a
lastly,
percentage of revenue,
interpret data based on
indicating how
construct graph.
efficiently they convert revenue into
So
profit.
firstly, divide the range
So
of
below is
production
a
cost
summary
into
of the dataset.
intervals.
The highest
Determining
production cost
interval using
recorded is
production cost million values.
97.2 million,
So
while the lowest
max
is
range is
11.8 million. And then the profit margin
97.2
range
and then
from
minimum range is
16.3
11.8.
to
So max value is
31.2%. And then
minus
there's a
minimum value
table
and
listing
then
of the
divided into
production
no
cost
of
and profit
classes.
margin for each
So
company
like this one
include
is
two facility
97.2
that
minus out
analyze
11.8
and comparison.
and then
Hello
divided
everyone,
into
my name is
10.
Muhammad Grafi bin Awang
So
and
the
my
answer
matrix
is
number is
8.4. And then calculate
YE22110007.
relative frequency and
And
cumulative
firstly, I
frequency.
want to explain
So
about data
determining the
description.
relative frequency
So
using
the
the
data
formula
set
below.
consists
So
of
the
production
formula
cost in a
is
million and profit
class
margin in
frequency
percentage
divided into
for
total of no
30
of
manufacturing
observation.
companies operating in Malaysia
So
during
class
September
relative frequency
2024,
example
while the data
3
includes a
divided
diverse range
into
of
30
companies
and then the answer
from
is
those in
zero
the
point
rubber
0.1.
industry to electronic and
And then next, the
pharmaceutical.
cumulative
So
frequency
there
is
are two
calculated by
key
adding the
performance
value of the class
indicators
relative
analyzed are
frequency progressive
firstly production
as
cost.
shown like the
So
graph.
this
Move on to the next slide, which is to measure of central location production cost mean. The first step is to rearrange the data of production costs in ascending order and using the sample mean formula to get the mean production cost. The mean production cost is 49.5 million calculated by dividing the sum of sample value 1484.2 million and the number of data points 30. The dataset includes value ranging from 11.8 millions to 97.2 millions, indicating a wide range of production costs. Outliers, which extremely high value 97.5 and 97.2. These outliers can skew the mean, making it larger than the actual typical cost. Move on to the next slide, which is to measure a central location production cost of median. From the table, we can see that the median value is at position 15 and 16. The median production cost is 46.3 millions, calculated as the average of the 15 and 16 values in the sorted data set. It represents the middle points where 50% of the costs are below and 50% are above. The median is not affected by high cost outliers, making it a more reliable measure of the typical production cost in this dataset. Next is to measure of central location production cost mode. From the previous table, we can see that the mode of dataset is 36.2 million unimodal as it is the value that appears more frequently. Move on to the next slide, which is to measure a central location profit margin. The first step, we need to rearrange, as usual, the data of profit margin in ascending order and using the sample mean to calculate the mean profit margin. The mean profit margin is 24.72%, calculated by dividing the total sum of profit margin 741.7% by the number of data point 30. This mean provides the average profit margin, which represents the typical profitability across the dataset. Since it considers all values equally, the mean is useful for understanding the overall trend. Is to calculate the measure of central location profit margin median. From the table, we can say the median values is at position 15 and 16. The median profit margin is 25.4%, calculated by averaging the 15 and 16 values in the sorted dataset, 25.2% and 25.5%. The median represents the middle value, meaning that 50% of the data points are below 25.4% and 50% are above it. Since the median is not affected by extreme values, or outliers, it gives a good indication of the typical profit margin in this dataset. In this case, it shows that the central tendency of profit margin is around 25.4%. The next one is the measure of central location, profit margin in terms of mode. The mode of the profit margin dataset is 21.2%, 22.1%, 23.3%, 26.3%, 27.6%, and 30%, as these values occur more frequently. The most common profit margins in the dataset. In this case, there are multiple modes, meaning the dataset is multimodal with several profit margins that appear more than once. Move on to the next slide. I want to share about the comparison. The average production cost is 49.5 millions, showing how much companies typically spend to produce their goods or services, while the average profit margin is 24.72%, showing how much of their revenue turns into profit after cost. Typically, lower production costs can lead to higher profit margins, assuming revenues remains constant. Range and impact of outliers. The production cost dataset range widely, which is 11.8 million to 97.2 million, with some high-cost companies potentially skewing the mean upwards. The profit margins is relatively consistent across companies with less drastic variation, suggesting a more stable profitability trend compared to production costs. To conclude, companies with lower production costs and higher than average profit margins are likely operating more efficiently. The median production cost, 46.3 million. This value represents the central points of production cost. Median profit margins, 25.4%. This indicates the central points of profitability. The median production cost is more reliable for understanding typical production costs compared to the mean just now, as it is not influenced by outliers. Similar to the median profit margin, 25.4%, provides a robust measure of central tendency as it is unaffected by extreme profit margin values. To conclude, the comparison shows that while production costs vary widely, the typical profit margins median remains stable around 25.4%. This stability suggests that despite differences in production costs, many companies are able to achieve comparable profitability levels. From the mode value just now, this shows that production costs are more concentrated around a specific value, while profit margins are spread across different levels, reflecting greater variability in profitability. Knowing the mode of both production cost and profit margin help us understand the most common value for each, giving us an idea of how most companies behave. The mode of production cost shows the typical amount companies spend to make their products, while the mode of profit margins shows the usual profit companies make after covering their costs. This helps us see what is typical for most companies in terms of cost and profit.
So this is part three of the descriptive statistics, which is to calculate the percentile and construct box plot between two KPIs. So the objective for this part is to calculate the percentile and box plot for production cost and profit margin of 30 manufacturing companies in Malaysia for the month of September 2024. And the key focus is that we want to identify the spread of data, groupings within the data set, and to visualize distribution, highlight the range, the interquartile range, and look for any outliers if there are any uh, using the box plot. So here are the result for the production cost in millions. So we got here, as you can see, Q1, which is the 25th percentile, we got 26.45 millions. The Q2, which is the median, 50th percentile, we got 46.25 million. The Q3, which is the 75th percentile, we got 67.7 millions. And the IQR, which is the interquartile range, this is a calculation to to rule out an outlier. So any numbers that is greater than this 41.25 million is we consider the number as an outlier. So how we calculate it is by subtracting Q1 and Q3 and Q1. So Q3 is 67.7 minus Q1 26.45, so we get 41.26 million. So since 97.2, which is a value in our sample, 97.2 million, which is greater than the third quartile, uh, it is considered as an outlier. So here we have found that 97.2 is an outlier. So after calculating the percentile for production cost, we construct the box plot for production cost, and from our analysis, we have found that the data is positively skewed with a long upper tail. As you can see here, the tail that reaches the 97.2, it is longer than the 11.8. So this is due to high production costs in few companies. The IQR, the interquartile range, shows that most companies have cost between 26.45 million and 67.7 million. So it's has a middle spread. We can see here that it reflects the spread on middle 50% of companies. And the skewness of the box plot, we can see that it is positively skewed, which is it is right skewed. This means that a few companies have much higher production costs than most, pulling the upper tail of the distribution to the right. And the outliers, as we can see here, 97.2 stands out as a potential outlier since it is outside the range of the IQR. So from this box plot, we have interpreted that the skewness indicates a significant variability in production costs. The median suggests that half of the companies spend less than 46.25 million, but the outlier highlights inefficiencies in a few companies that needs cost control measure. And now moving on to the percentile of profit margin. As you can see from our summary of calculation, using the same calculation for percentile, we got the Q1, the 25th percentile at 21.875%, the median, which is the 50th percentile, 24.35%, Q3, the 75th percentile, we got 27.6%, and the IQR, interquartile range, by subtracting Q3 minus Q1, 27.6 minus 21.75, we got 5.725%. So it is within the range of the outliers. So they are since it is within the range, so no outliers are detected. And lastly, similarly for production costs, we have construct a profit margin box plot. As you can see from the graph, the data is slightly negatively skewed. This indicates a concentration of higher profit margins, but a few lower values pulling the tail. So as you can see, the tail here, 16.3 is longer than the 31.2, which is why it's negatively skewed, but just slightly. Unlike the production costs, there are no outliers in the data set. Everything is within the range. And for our interpretation of profit margin, we think that profit margin are more consistent, with most companies performing close to the median of 24.35%. However, a few companies with lower margins could benefit from operational improvement. And finally, to summarize, the percentile and box plot that we have constructed and calculated for production cost, it has revealed several key insights. It has wider spread and are positively skewed, but with a notable outliers at 97.2 millions. Companies with high this indicates that companies with high production costs may need to improve cost efficiencies to remain competitive. Meanwhile, for profit margin, it shows a stable and consistent distribution with a tighter IQR. And this shows that companies with low margins should explore better pricing strategies or cost saving measures.
My name is Christy. student ID YE22110002. So I will present my part 4, measure of dispersion. There are 4 calculations needed in measure of dispersion. First, range, where the maximum value minus minimum value. Second, mean absolute deviation or MAD, where unit measurement minus mean return, then subtotal next divided by the total number of data value. Thirdly, variance and standard deviation. This calculation have 2 parts. The first, to find variance, where sum total of unit measurement minus mean, then divided total number of data value, deduct 1. Next, in second part, take the result from part 1 and square root it. Lastly, coefficient of variation or CV, where the standard deviation divided by mean. Here are the results of the measure of dispersion. The data show that production costs have much higher variability compared to profit margin. The range of production cost is 86, indicating a large difference between the highest and lowest values, while profit margins have a smaller range of 14.90, reflecting more stability. Similarly, the mean absolute deviation for production costs is 21.65, showing greater variability around the average compared to 3.12 for profit margins. The variance and standard deviation also highlight this difference, with production costs having significantly higher dispersion, which is variance 646.10, standard deviation 25.42, then profit margin variance 14.46% and standard deviation 3.80%. Finally, the coefficient of variation confirm that production costs are more unpredictable, with a CV of 0.51 compared to 0.15 for profit margins, which indicates more consistency. Overall, production costs are less controlled, leading to greater uncertainty, which profit margins are more stable and predictable. To conclude my presentation, what can be analyzed based on the data is that first, variability in production costs. Production costs show high variability, indicating potential inefficiency in operation. By addressing this variability, businesses can gain better control and predictability. Second, stability in profit margins. Profit margins are stable, suggesting a consistent relationship between costs and revenues. This indicates that the current operational model is effectively maintaining profitability. Third, focus areas for improvement. Given that production costs are more variable than profit margin, businesses should focus on stabilizing and optimizing production costs to improve efficiency. Fourth, potential impact. Reducing variability in production costs can directly enhance profit margins, leading to better financial health and allowing for reinvestment in technology or quality improvement. Lastly, efficiency versus profitability. While it's important to reduce production costs, businesses should also consider how these changes affect profit margins to ensure they meet overall financial goals and maintain product quality.
Selamat sejahtera, my name is Nurul Iza binti Glenn. My matrix number is YE22110010. My part is part 5, calculate the interpret measure of association between the two key performance indicator. So this is the formula of covariance, which x1 minus x bar times y1 minus y bar divided to n minus 1. For the formula correlation is xy divided sx times sy. This is for our mean of productions, which xi. We calculate total production cost divided into number of companies, so we get 1484.2. We divide it into 30, so we get 49.5 million. So mean of profit margin, we get yi. We get total profit margin divided into number of companies, so it's 741.7 divided into 30. So the answer is 24.72%. So this is the table for sample covariance of company. First, we have to find the deviation for xi, x bar, and y bar. To calculate the deviation, first I'm searching and find for deviation xi and x bar, which the total production cost I divide number of companies, which I get 449.5 million. So subtract the mean from each data point. Examples: Panamlina World Transport and Senen Berhad. I calculate 11.8 minus 49.5, so I get the answer for negative 37.7. So I repeat for all the data points, so I calculate until 30. So for deviation xi, x bar is negative 246,000,000. Next, I'm searching for the deviation for yi and y bar. Same also, I'm searching for the mean, which total profit margin I divide into number of companies. 74 1.7, I divide 30, so I get 24.7200. So subtract the mean from each data point. For examples, Panamlina World Transport, yi and y bar, which is 31.2 minus 24.72, so I get 6.48. So I repeat for all the data points. I'm searching for the deviation yi and y bar, so the total is I get 0.12 percentage. And for the multiply deviation, for each company, the product of the deviation as I calculate is deviation x and deviation x times deviation y. For examples, Panamlina World Transport, Senen Berhad, deviation x times deviation y. For the deviation x, negative 37.7 times 6.48. So I get the answer negative 2442690. So I calculate until 30 companies, and I sum the deviation, which I get negative 25 127 80 4.00. For the formula convariance is deviation x times deviation y divided n minus 1. So I'm substitute the value, which negative 25 170 at 4.00 divide 30 minus 1. So I get the answer negative 86.65. For the formula correlation is sxy divide sx times sy. So negative 86.65 I get from the answer convariance. So I divide 25.42 times 3.30. So I get the answer for the correlation negative 0.60. So analysis